Hey guys, let us learn point method or geometric method today. Now in the earlier lecture, we learned two other method, that is the ratio method and the total outlay or total expenditure method to measure the price elasticity of demand. But the problem was that both those methods they fail to measure the elasticity of demand if it has to be measured at a particular given point on the demand curve, and hence Professor Marshall has developed this point or geometric method. Now with the help of this particular method, it's very easy to find out the elasticity of demand at any particular point given on the demand curve. So let us see the formula of this method. Don't worry, since the name is point or geometric method, don't worry here, you are not supposed to do any difficult calculations. The method is quite simple, only one single formula is there. Let us move forward. Point elasticity of demand, I have written the formula on the board. ED is equal to L upon U. Now what is this L upon U? That is lower segment of the demand curve divided by upper segment of the demand curve below a particular point. Whatever point is given, we have to find elasticity of demand at a particular point. So whichever point is given, we have to simply calculate. The formula is ED equal to lower segment upon upper segment. Very simple formula, L upon U. That's it, very simple. The same formula will be applied everywhere. Now let us continue ahead. Demand curve may be either linear or non-linear demand curve. That means it may be a straight line. Linear means straight line demand curve. Non-linear means it may be curvature demand curve. There might be a curve. So both the method we have to use the same formula only. Let us see how it is. First type, linear demand curve. When the demand curve is linear, that is straight line, what we have to do is we have to extend the demand curve on both the ends to both the sides to meet the x and y axis, and wherever our demand curve is meeting the y axis, we are naming it as point A, and wherever it is meeting the x axis, we are naming it as point B, which I have shown in red pen. Point A, point B, we have extended our original demand curve and we got these 2 points, that is point A and point B. We have got them. Now let us assume that the length of AB is 8 centimeter, and assuming this total length of AB 8 centimeter, see I have shown different measures with the help of green pen, that is the first point from A to from point A to the point P2, it is 2 centimeter. Then from point P2 till point P again it will be 2 centimeter. So what my point of telling you is that you see in the green pen, with the green pen I have shown clear cut measures for your better understanding. Total length of AB is 8 centimeter. So but natural, at the center, at the half, at the midpoint P, so from PB it will be 4 centimeter, and that side upper side PA will also be 4 centimeter, which again will be divided into 2 centimeter, 2 centimeter. So for your better understanding, I have shown this length measurements in green pen, with the help of green pen, so that you will understand it easily. Now let us continue. First case, at point P, we are measuring elasticity of demand. So simple formula, as I told you, the formula will be same everywhere, lower segment upon upper segment. So let us find elasticity of demand at point P is equal to L upon U is equal to, in this case, since we are measuring at point P, so here the lower segment becomes PB and the upper segment becomes PA, which I have written clearly on the board. So PB upon PA, which will be equal to 4 upon 4. The answer is 1. So at point P, we are finding that the demand is unitary elastic. That means ED is equal to 1. I have written clearly everything on the board. Now we are considering second case. At point P1, at point P1, the elasticity of demand will be again the same formula, lower upon upper. So lower portion here is P1B. which measures to 2 centimeter as I have marked with the green pen. Then upon P1A, the upper portion is more. So it is measuring in this case is 6 centimeter. So 2 upon 6. So the answer comes as 0.33. Hence, the elasticity of demand is less than 1, and all of us know that if ED is less than 1, then it becomes the case of relatively inelastic demand, less responsive demand. So it is inelastic because it is less than 1. Now let us consider third case, the one more case at point P2, which lies in on the upper side. At point P2, the elasticity of demand can be calculated as same formula, lower upon upper. So here the lower portion is P2B, upon the upper portion is P2A. So the measurements will be 6 upon 2, which will give the answer as 3, and hence the demand is relatively elastic demand because ED is greater than 1. So all the three things we have done. I hope you understood this. At point A, our elasticity will be infinity, and at point B, it will be 0, as is shown on the x-axis is 0. So this was the first case, that is the case of if your demand curve is linear demand curve. Now let us move on to non-linear demand curve. Non-linear demand curve means it's a curvature demand curve which is convex to origin. Now in this case, whenever we want to measure the price elasticity of demand on the non-linear or curvature demand curve, simple formula, again the same formula we will use, same, that is L upon U, lower segment upon the upper segment. And here also we will make the same arrangement in the diagram. We'll make the same extension to the demand curve. But here what we will do is, since our demand curve is curvature, that is non-linear, so we will draw the demand curve which will be tangent. Tangent means touching. It will touch our A and B axis. We will extend the demand curve which will touch the y axis at point A, and it will touch the x axis at point B. Now many students are confused about how to draw the diagram. But dear students, you may draw the diagram in any way. That means if you want, you draw the AB first, then you draw the curvature demand curve. Or if you are comfortable, draw the curvature demand curve, then take one middle point from it and then draw the AB. Whichever way you are comfortable. That's it. You should get the diagram. That's the point. Then we use the formula elasticity of demand at point E here in our case. Formula is lower segment of the tangent below a given point, that is L, upon upper segment of the tangent above a given point, that is U, upper segment. Now in this case I explain it simply. If EB equal to EA, that means lower segment is equal to upper segment, the answer will be 1 because both the sides we get the same distance. Then in that case ED equal to 1, it is unitary elastic demand. Everything is clearly written on the board. In second case, just remember it simply. If EB is greater, if the lower portion is more, then your ED will be greater than 1. So it is relatively elastic demand. If EB is greater, your elasticity of demand will also be greater than 1. It's easy to remember. So it will be relatively elastic demand. And in the third case, if your EB is less, that means lower portion of the demand curve is less than EA, than the upper portion, then in that case you will get elasticity of demand less than 1. Your ED will be less than 1. So it will be relatively inelastic demand. So in short, I revise. EB equal to EA, both portion equal, unitary elastic. If lower portion is greater, then greater than 1, so relatively elastic. If lower portion, lower segment of the tangent is lesser, then ED less than 1, so relatively inelastic. That's it for today. So today we learned point method or geometric method. Now do like and subscribe to my channel and share this video if you like it. Thanks for watching.